During disasters, timely access to accurate information can be the difference between safety and harm. However, misinformation often spreads rapidly in these situations, creating confusion and hindering effective response. Establishing clear, reliable communication channels between the public and first responders is essential to direct people to safety and ensure critical needs are addressed. Through the MIT Generative AI Impact Consortium, researchers at MIT Lincoln Laboratory's Human Resilience Technology Group have collaborated with MIT faculty and students to develop Crisischat. By centralizing communication through Crisischat, the system aims to connect the public to resources they need during an emergency. In this web-based prototype, we can see a user asking Crisischat where they can shelter. The chatbot replies, seeking additional information about their household. Using this information, the chatbot utilizes a decision support dashboard for emergency managers and directs the user to the nearest shelter that can accommodate their needs. But only some people will use the chatbot to request help, while many others will head directly to shelters without interacting with the system. To ensure efficient resource allocation, the team developed a needs estimation model that predicts total demand, both from chatbot users and non-users. The model takes in two inputs: simulated households in a region with demographics including age, disability status, and transportation access, and simulated flood scenarios from physics-based models that forecast flood depths across the region. It then learns to predict demand based on the simulated population's needs as floodwaters rise, determining who will require shelter based on both the severity of flooding in their area and mobility capabilities such as age, transportation access, and income. This demand forecast then feeds into an optimization model that estimates each shelter's effective capacity by accounting for non-chatbot users who will proceed to their nearest shelter. For chatbot users, it optimizes shelter assignments to maximize social welfare, ensuring that those with the greatest need are matched to shelters that best serve them while balancing travel distance and resource availability. Additionally, the model can predict which populations are more or less likely to adopt chatbot technology. This allows the optimization model to account for shelters at risk of reaching capacity, and the chatbot can then direct users towards facilities with available spaces that meet their specific needs. Using a generative AI-powered chatbot as the interface layer on top of this framework allows people to describe their situation conversationally, rather than requiring them to navigate complex forms or drop-down menus. Further development is needed to integrate Crisischat into widely used messaging platforms, such as ChatGPT, iMessages, SMS, WhatsApp, and Facebook Messenger, making it accessible where people already communicate. We envision more comprehensive features like multi-language support and expanded needs-based guidance. Localized hazard reports would create a bidirectional information flow that enhances situational awareness for emergency managers, who in turn could use the platform as a channel for disseminating verified information directly to affected populations. By integrating demand estimation with natural language communication and decision support tools, Crisischat represents a step towards more coordinated and effective disaster response that serves both the public and emergency managers.